Hello, my name is Pekka Sillberg. I work at Tampere University Pori unit, and at GPT-Lab I do many kind of hardware and software application solutions for many kind of needs. Well, Professor Pekka Abrahamsson kind of come into the Pori unit, and he take everyone in the software business together. So it's like not choosing, but it's like just moving along with the flow. Well, getting new or old hardware is always like early Xmas, Christmas, and I wanted to experiment with the NVIDIA's computing hardware. They have very many GPU solutions, and I like building and doing stuff with the computers. So also like measuring, benchmarking, doing energy utilization, like putting cables in and see how many watts this part consumes or something is interesting part for me. So first we have so bring us some 10 older GPUs and say, hey, we need to get this running. So in the first, we needed to get some smoke out of the hardware, well, the good smoke, of course, because we know that electricity and smoke is not good. So finally, I make the first stuff in my own PC at home, but then we started to move in that, okay, we need more GPUs in one server. So the GPU farm, or how to say it, we visited other units and places like SAMK and Tampere Hervanta campus, and we talked with another hardware people there and got good advices, ideas for how much stuff, how many price is this, and so that was good starting point for building the proper hardware. Well, this is always like a compromise between price, performance, and many kind of things. Should we use new or old hardware? What kind of CPU, memory, GPU, storage solutions we need? Because we have the many GPUs. What kind of topology we need for GPU communication or GPU CPU communications, like are they single rooted, dual rooted, or directly connected to the CPU? So this affects to the GPU peer communication performance, and they also have like ways to mitigate this issue, like NVIDIA's NVLink and AMD have own stuff for their Instinct brand products. So choosing the best parts is like top of the line is probably very pricey or something, but it's not always the most appropriate for our current need. So what this all leads is to analysis paralysis. So you cannot act and you're just thinking and thinking. So important thing is to stop considering and start acting. Well, because we first started it with the old hardware, and we are thinking that okay, we use old hardware, old servers to test this thing. So we need to consider that the old hardware has very limited or non-existent extension options. We might not have GPU power cables, or they are bad. I buy some adapters, and cables are quite bad. So if you just like take the cables out, and it will not work in the long run. So something. These have many opportunities, but I see that the most impressive or the useful thing is the streamlining the backend implementation. Like you could instruct the AI or LLM to receive the data and tell it in your natural language that okay, this is what you need to do on this case, and this case. So you are making like a rule-based implementation for the system. So this would be the interesting topic for me. Well, of course, the AI can hallucinate and stuff like that. And maybe the bad thing is if the AI is told that, okay, remember this and this and handle the state changes, and suddenly it forgets and behaves badly. So we can miss the critical information and some notifications. So it just doesn't work correctly. Well, I anticipate that we are moving toward working with the information inferred from the data, for opposed that now we are working to get the plain raw data inside the system and then try to make the all kinds of bits and pieces to work.